Welcome to the first video of the packet injection series. In this video tutorial, I'll teach you how to inject your very first packet into the network. What we'll try to do is make a packet in memory and then send that packet out onto the network. We have discussed some of the fundamentals in the previous presentation. In this video, we'll go ahead and implement those fundamentals in the form of code and see it work. Now, to demonstrate the power of packet injection via raw sockets, in this example I will create a packet of 1024 bytes, all bytes filled up with the same value, that is 41, which is nothing but the ASCII value of capital A, and send it out onto the network. Now you might ask, what is the utility of sending out such a garbage packet onto the network? The answer lies in the fact that this is just to prove the power which packet injection via raw sockets provides a programmer. A programmer can absolutely send any packet he wishes, no matter whether it conforms to any protocol specification, onto the network using raw sockets via packet injection. Having said this, let's go ahead and look at the code. Let's discuss each of these functions first. Please refer to the raw sockets programming tutorial for fundamentals on raw sockets. I'll be skipping the functions which have already been discussed there. You're all familiar with the create raw socket, which creates the raw socket, and the bind raw socket to interface function. Both of these have been discussed at length previously. Now coming to the third utility function, send raw packet. Now what this function does is it takes input the raw socket which was created by create raw socket, and then also a packet and the packet length as input, and then simply writes that packet onto the raw socket. This is how we send the packet onto the network. So first we create a raw socket, then we go ahead create the real packet, and then we call send raw packet with the socket as well as the packet and the packet length, and it just writes that packet onto the raw socket. There was a problem, it returns a 0, else it returns a 1. Now coming to the main function, argv1 is the name of the device, for example ETH0, and argv2 is the number of packets to send. Now this is the raw socket which you will use for our sending purposes. This buffer is nothing but the packet and of size packet length, which is defined as 1D024 above, which will be used to construct the packet here. Num of packets is nothing but the number of packets which one wants to send, and this is the argv2 input which the user gives. So what we do is we set the packet to all A's as we had discussed previously by using memset. Then we go ahead and create the raw socket with a type of ethp all. What this actually means is we are telling the kernel that we are going to send all the headers, even the link layer header, everything. So do not try and add any header to this, just send out the packet as is. Then we go ahead and bind this raw socket to the interface, which is argv1 from the user input. argv1 most probably would be ETH0. Then the number of packets is nothing but an A to I conversion of argv2. Then we run a small loop over number of packets, decrementing it every time, and in that we call send raw packet, giving it the raw socket and the packet as input. If there is a problem, then we print out the error, else we just print packet sent successfully. So as you can see, this is a very simple program. All we have done is created a character buffer of size 1024, which is our packet size, filled up that buffer with all A's, and we just send out that buffer over the network. That's it. Now let us try and compile this program. Compiles fine. Let's try running it. As we know, the first input is ETH0 and second input is number of packets, that is, let's keep it as 1. Now the point is, even if this program executes, there has to be a way by which we can find out whether the packet was really sent out to the network. For that we will have to use some sort of a sniffer utility which will actively look onto the network and tell us if the packet was sent out or not. So we have two options for this. The first is to use TCP dump, which we've discussed previously. Give it the interface, tell it to dump the whole packet. S stands for snaplen, and then be a little verbal, then print the packet totally. Now we give it a filter. So as you can see that our packet just consists of all A's, which means it does not conform to the IP or the ARP or any other protocol. So we need a filter which can weed out all those packets. So let us try and do that. Not inside bracket IP or ARP, which means all packets which are not IP packets or ARP packets will only be dumped now. We start TCP dump. Alternately, we can use Ethereal to do the same job. We mentioned the not IP or ARP same filter here, and then we go ahead and start the sniffing. Go back here, execute the program, packet sent successfully. Let's first look at what TCP dump gives us as output. As you can see, the whole screen has been filled up. Here we are. So a packet was received from this MAC address to this MAC address. In both cases, the OUI of the manufacturer could not be detected, and the ether type is also unknown and is coming out to be 4141. Length of the packet though is 1024, and this is how the entire packet looks like. It's nothing but just 41s getting repeated, or ASCII values A getting repeated all through the packet for 1024 byte values. So as you can see, we have been successful in sending this packet out to the network. Let's just confirm the same result with Ethereal. In this case also we've seen a packet of 1024 bytes, and which has an Ethernet header, destination for all 41s, source all 41s, type once again unknown and all 41s, and it says it has a data portion of 1010 bytes. It's nothing but 1024 minus 14 for the Ethernet header, and the packet dump once again consists of nothing but all 41s. So as you can see, we have successfully transmitted a packet containing absolute junk data onto the network, and which is relayed as is on the network. So now we are able to understand the amount of power packet injection through a raw socket provides the programmer. In the next video tutorial, we look at how to create an Ethernet header, a meaningful Ethernet header, and send it out onto the network. That's it, folks. See you in the next video.